Hello, welcome to my channel. In this video, we are going to be taking a look at a problem under free fall. And the problem that we are going to be looking at is given in the form of a statement. So we are asked to determine the height of a building when a metal is dropped from the height and the sound of that metal hitting the ground is heard after 4 seconds later. So to solve this problem, we must first of all understand what the problem is all about. And we realize that a coin was dropped from a particular height. After hitting the ground, the sound it made reflected back to the thrower after 4 seconds, right? So what we can do in this problem is to split the timing into two parts. So the first thing is to say, okay, the time it takes for the coin to drop from that height to the ground. And the second part of the timing is the time it takes for the sound to get to the thrower. So we now see that the timing will be in two parts. So the first part will be time t1, second part will be time t2. So to solve the first problem, we use this equation, S equal to ut1 minus half of gt1 squared, where S is the height of the building, U is the initial velocity of the coin when it is dropped from that height. Then everything here is known, acceleration due to gravity, the first time. So at the end of the day, we notice that our initial velocity is 0 and our S, because it falls downward, we take our S as negative. If it goes upward, it's positive. So in that case, this equation will reduce to minus S equal to 0 minus half of gt1 squared, and which reduces to S equal to half of gt2 squared. So this is the first part of the timing. So the second part of the timing is when the sound travels back to the thrower, which is time t2, which will be the second part of the timing. So we have this formula that takes care of that particular scenario. S equal to vt2, where t2 is the time taken for the sound to travel back to the thrower. It will travel this distance s, no longer 2s, is distance s, where our v here is the velocity of the speed of sound in air. Now, because we know that this equation and this equation are equal, this s here and this s are equal, we can equate the two of them. That's one. Then two, we notice that if we had this t1 plus t2, that will give us the total time it takes for the thrower to hear the sound, which is 4 seconds. So we expect that t1 plus t2 must be equal to 4 seconds. And that's giving us t1 plus t2 equal to 4 seconds. So if we equate these two, we have half of gt1 squared minus a is equal to vt2. Okay, now if we eliminate t2, that's to make t2 in terms of t1, then we can have t2 equal to 4 minus t1. So if we substitute 4 minus t1 as t2 in this equation, we'll get half of gt1 squared equal to, our v is here, 4 minus t1. If we expand, we have 4v minus vt1. Now, if this 2 goes to this side, it becomes gt1 squared equal to 8v minus 2vt1, which is giving us this expression. So if we rearrange this equation, it gives us this. And we can see that this equation takes the form of a quadratic equation, right? And we can solve this equation for t1 using the almighty formula for quadratic equation. Okay, so already we know the value of g, which is 9.8. We know our velocity, which is the velocity of the speed of sound is taken to be 340, right? Then 340 times 8 is multiplied by this one, which is equal to 0. So if we use this formula and we substitute what we need to substitute as the value of b, the value of a, the value of c, we'll get our t1 equal to 3.79 seconds and this one is supposed to be t2, and t2 equal to t1. Yes, so we have two answers for t1 as this and this. But we can see that we cannot use a negative timing. So this one will be the correct timing for t1, right? So if we substitute this value back into the original equation for s, we'll get s equal to half of gt1 squared multiplied by 9.8 multiplied by this. That will give us s equal to 70.38 meters. And that will be the distance of that will be the height of the building. So this method can be used to determine the height of a mountain when a coin or any stuff that can produce a sound. It can be used to determine the height of a mountain. I hope this helps. Please like, share, and subscribe. Thank you.